Let's start, pick a random one. Let's see. Okay, we'll start here. Somebody describe Boyle's law. What is Boyle's law? Who can tell me what Boyle's law is?
It's temperature constant, pressure rise and volume decrease.
Yeah, good.
Pressure inversely proportional to volume.
Yeah.
P1 equal to P2 B2.
T1 V1 over T1. Yeah. So it's constant temperature. Then it's going to be, well, it's going to be directly proportional or indirectly proportional to pressure and volume.
Indirectly.
Inversely.
Yeah, that's right, indirect proportional, because it's on the top, which leads us on to the next question. What is the ideal gas law, sometimes called the general gas equation or universal equation? What is that one?
P1 V1 by T1 is equals to P2 B2 by T2.
Good. Describe a basic thermodynamic engine, if you can. If you picture that diagram we had on the first day, what is the basic thermodynamic engine? Give you a clue. It's got
Once more.
Q's and W's and everything, that sort of thing. So, a basic thermodynamic engine.
Heat energy is converted to work.
Yeah, and then unfortunately, some of the energy is wasted, so we'll get the energy going out, the Q energy. So Q for
Q
that.
minus W.
Yeah. Okay. In your words, what is the difference between a piston engine and a gas turbine engine? The working cycle. There's a few variations in this one, but what's the main differences?
Constant volume and constant pressure.
Yeah, which one's which?
Constant volume piston engine and constant pressure gas engine.
Good. Which one is a constant power? So which one's a constant power out of the two? Ah. So which one always has power available? That makes it easier. Piston engine or the turbine engine?
Question please, sir.
Which engine always has power available? Which one's got the constant power? Is it the gas turbine or the piston? No, it's the gas turbine. Remember, in a piston engine, it's intermittent. You only get one power cycle for out of the four. So you get the induction, compression, power, exhaust. So on the power cycle, that's when the power happens. On a gas turbine, once you ignite the flame, the fuel, you've got power there all the time. It's a constant burn, where a piston engine is an intermittent bang. That's when you get the bang, 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 bang. Where a power engine, gas turbines are a straight power. Once you've ignited it, you've got power there. All you need to do is add more fuel or less fuel, but the power is always available. Okay, so a piston engine is intermittent, whereas a gas turbine engine is constant. It's all dependent. What is another name given for the gas turbine cycle?
Brayton cycle.
Brayton cycle, also known as the Joule cycle, but more commonly known as the Brayton cycle. And just for a bit of background, your piston engine is called the Otto cycle, as in O-T-T-O. Okay. Okay. What's the purpose of a compressor?
To compress the air in each stage.
Yeah, depending on what type it is, that's what's due. Air gets driven in, compress the air, and then deliver it to the combustion chamber. Good. Describe a single spool engine. Yeah, it's a pure jet engine. Yeah, there's no bypass. There's nothing like that at all. And what is a spool? What's a spool?
Compressor, turbine shaft, and turbine.
Yeah, that's it. Yeah, compressor shaft and a turbine. Okay. What is a turboprop engine? Just keep it basic. What's a turboprop engine?
Which has propeller.
Yeah. What is it? What is a turboprop engine? Engine is it? Well, you can have both. But generally, what is it?
Engine with propeller with more turbine stage.
Yeah, that's good. That's an extra bonus point there. Yeah, more stages for a turboprop engine. So basically, a gas turbine engine, it can be fixed, it can be free, and you quite rightly said, usually more stages, turbine more stages. Okay, so yeah, and we need the more stages in a turboprop to extract more energy from the gas flow to help turn the free turbine, if it's a free turbine, a fixed turbine, for the propeller to move. Good. What are engine notations? What are engine notations? What do we mean by the terminology engine notations? Or give me an example of some engine notations.
Yeah, notation means, isn't it P1, T1?
Yeah, it could be that. Give me some other letters.
P2, T2, that is for low compressor delivery, and P3, T3.
Yeah.
HP compressor.
Yeah, good. And if I said N2 on a triple spool engine, what would that mean?
If N2 is intermediate pressure.
Yeah, or intermediate spool. Yeah, good. Because remember, N is for speed, so that'd be the spool, the actual intermediate spool, interstage spool. Good. So remember, N's for speed, P for pressure, T for temperature. Okay. What are the two main methods used for engine ice protection?
Hot air and electric system.
Yeah, good. What are the two types of compressors?
Centrifugal compressor and axial compressor. Yeah. Axial flow compressor.
Now here's one to think about. Which compressor uses diffuser vanes?
Centrifugal.
Yeah, centrifugal. Yeah, good. Now, an axial flow has a diffuser, but it's not vanes, it's just the shape. Yeah, but the centrifugal compressor has the vane, the diffuser vanes. What's the purpose of a stator vane? What's the purpose of a stator vane? So you got the rotor, and then the stator. So what does the stator do?
Stator, the one which doesn't rotate.
Yeah, it's stator for stationary. Yeah. So what's its purpose?
It's for compression?
No, it decreases the velocity, isn't it?
Think about the airflow.
Yeah, and
So
direct.
It does increase pressure, yeah, but what else does it do? So if it's not moving, what's it doing apart from increasing pressure? So we've got the rotors spinning around, but the stators are stationary in the stage. So what's the purpose of a stator? Yeah, go on. You're not soon to say it. Does the same job as an IGV. That helps.
Redirect the air.
Yeah, directs there at the correct angle to the next set of rotors. Yeah, basically it's just a guide vane. That's what it is. Basically a standard guide vane. Okay. What is the purpose of blade twist or stagger?
To,
That makes sense.
to maintain the same angle.
Yeah, uniform airflow over the whole part of the blade. Yeah. Okay. Describe what happens when a compressor blade stalls. So what happens when a compressor blade stalls?
We lose the thrust.
Yeah, you lose a bit of
Power
thrust.
loss.
Yeah.
And
yeah,
total temperature rises, vibration.
yeah, all that sort of thing. In other words, we've lost if it's a wing, it'd be lift, but in our case, we're thrust, so there's no air to grab onto. So turbulent air, we've lost all connectivity with the air. Yeah. In other words, we'll get a stall, and you quite like said, we'll get symptoms of a compressor stall, vibration, rumbling noise, EGT, and fail to accelerate, and that sort of thing. Good. Okay. How many types of burners are used? What are the two main types?
Two types.
Two types, good. And what are they? What's the name of the types?
Vaporizing and atomizing.
Good. Vaporizer, atomizer. Which one preheats the fuel?
Vaporizing.
Vaporizer, also known as a
Hockey stick.
hockey stick. Good. Good, good, good. Which one not had for a while? What are the two main profile shapes of a turbine blade?
Impulse and impulse reaction.
Good, yeah. Happy smiley face or Nike tick or Usain Bolt. Okay. That one. Why are compressors and turbines carefully matched? Why is it essential to make sure we match the turbines and compressors?
To avoid the surge or compressor choke.
Yeah, good. So you remember which way it works.
If it is too high,
yeah,
it will be choke. Compressor will choke.
good. Yeah,
And if too low, it will surge.
fantastic. Good, 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 good. Okay, describe turbine blade creep.
Three type of creep.
Yeah, just what is creep? What is a turbine? What is happening when we've got turbine creep?
Permanent deformation of turbine.
Yeah, it's stress. It's stretching due to centrifugal load. It's trying to stretch itself past. So we've got the three systems: primary, secondary, and tertiary. Primary is initial, secondary normal working life, and tertiary that's when it potentially
It's final growth.
Okay. Why do we use thrust reverse? Why do we use thrust reverse?
Pardon, sir?
Why do we use thrust reverse systems?
To decrease the rearward thrust.
Not decrease the rear thrust. What does it assist?
To stop the aircraft.
What does it help? Yeah, braking.
Increase the braking efficiency, right?
That's it. That's what's looking good. Increase the braking efficiency. Good, good, good. What are the three main types of thrust reverser?
Cascade one.
Yeah.
And clamshell.
Clamshell, yeah.
Retractable ejector.
Retractable ejector. Good. Good, good, good. Okay. How is thrust reverse prevented from operating in flight? So how do we not activate thrust reverse in flight? What prevents it from activating?
Mechanical lock?
Yeah, you can mechanical lock. Gave the back to idle, mechanical one there. But yeah, once on the ground, the wait on wheel switch. Even if we brought the idle back and then tried to select reverse thrust, it won't activate it because the wait on wheel switch hasn't engaged. Okay, so the electrical circuit of that would not be engaged. I believe some aircraft, not all of them, you can pre-select it, but if you're at idle, then you're almost on the ground because you've got the throttle back. Now, most aircraft need some sort of power as they're landing to allow for the angle of attack. So you still a reasonable amount of power, maybe 70%, 80% possibly. So you're not fully idle before you landed normally. But some aircraft can pre-select it. Certainly on some tornadoes, we could rock the throttles out. So as soon as it landed, the mechanism was there ready, but wait till it got the wait on wheel switch and then engage it. Okay, how is noise measured?
Decimals?
Yeah, decibels, yeah, good. What are the two? We've got low frequency and high frequency. What was the names we gave to the high frequency? For both of them, high frequency and low frequency, we gave them a certain name.
Yeah. High frequency is small eddies.
Yeah.
Small eddies.
And low frequency is large eddies.
Good. Where do we find the small eddies? Is that where do we find those?
Near the shock wave.
Yeah, near the exit of the
exhaust duct. Yeah.
Good. Right, so I'm now looking at. What is the most common type of subsonic intake? What's the common name for a subsonic intake?
Pitot type.
Pitot, yeah, good. All right. If in a supersonic intake, if it's going supersonic, what is the position of the wedge?
If it is supersonic, the wedge will be lowered, which dam valve will be open to.
Fantastic, brilliant. Okay. When system uses fast and slow cycling speeds, which one would be used at low temperature?
Slow cycle.
Slow cycle, yes. Slow. Just think low temperature, slow and low, and then fast.
High.
High, yeah. Good. Righty. Let's see which one I've not done yet. Oh yeah, which type of engine has a booster fitted to it? So which type of engine has a booster? So what was a booster called? Or what is a booster? Yeah. So it's going to be a low bypass or high bypass engine. Yeah, high bypass. So the LP compressor will have a big fan attached to the front. So they don't tend to call it an LP compressor anymore. The Americans tend to call it a booster. Yeah. Don't get mixed up. If you do module 16, boosters are something that's called turbochargers. But basically, a jet engine is a turbocharger. It's squeezing air and going at the back end. That's all it is, a glorified turbocharger. Oh, great. Let's see. What are the main types of airflow control used in a gas turbine engine? Main types of airflow control, the two main sort of types I mentioned.
Is it inlet guide valve or?
Yes, IGBs. What else is there?
And Nozzle guide vane.
No, that's not airflow control. Yeah, I mean, it does control the angle, but we think about airflow control, we think about the cold section of the engine. So what's that going to involve?
Diffuser is also there.
It's not controlling the airflow, it's directing airflow, but it's not controlling. So
Then stator.
Not a stator. Close, very close.
Variable guide vane.
Yeah, variable guide vanes. We've got variable guide vanes and also
Fixed guide vane.
not fixed ones. If they're not fixed, they must be variable.
Variable, yeah.
Variable guide vanes, yeah. They're the ones that send back an LVDT sensor position, again to FADEC. We've got VSVs. What else have we got? We've got VSVs, VIGVs, and what else?
RGB.
No, they don't move. What else moves? Engine valve. What other valve moves with airflow control? So you've got VIGVs, VSVs.
Bleed valve.
Bleed valve, yeah, there we go. And there's a couple of types we looked at. There was a round one that goes round the engine, slides back and forward, and the one that's on maybe the top of the engine takes a bleed from the middle of the compressor, okay, which opens and closes, prevents choking of the rear of the compressor. So if I said to you the bleed valve was closed, is that the engine running at high RPM or low RPM if the bleed valve is closed?
High RPM.
Good, yeah. There's no point in bleeding air off at high RPM because we're not going to take off. So the bleed valve will be open at low RPM or start up, and that sort of prevents choking of the rear compressor. Then once it's stable, once you've got the momentum of gas going through the engine, it will slowly close off proportional to RPM, which is controlled by fuel pressure. Well, the only thing that controls fuel pressure is mechanically is the fuel pump. Yes, the FADEC, if it's electronic, will sort out as well. But the faster the fuel pump's going means there's more flow means more pressure means it will move the bleed valve to a closed position. Okay, so good. Yeah, a lot more to think of there. Right. Which one not done? No, that's not too bad. Not too bad at all. Right, that's just a few sample questions out of the ones in your new book one that you'll get hopefully soon that you can go through in your own time. What I'm going to do, what's that, 3:45 now? Right, it's about half an hour earlier than planned, but to be honest, that's probably a good point to stop. A lot of revision questions there. Make some notes in your old books and any questions you want to go across before the weekend, because we'll recap book one and we'll recap book two once we finish it by Friday, before we set off the weekend. We'll probably start book three maybe Friday afternoon-ish, Monday, then Tuesday, and book four and so onwards. So we'll start book two fresh tomorrow. That's as far as I'm going to take it today. A little bit earlier than planned, but I'll give you a little break. All right, so you can do a little bit of revision or whatever. And then we'll start fresh book two tomorrow. And I'll keep in touch with Sanjeev to make sure. I'll keep an eye on the connection because it seems to be taking a lot of time to connect on the Teams for some reason.